Hello subscriber, today our topic is the first and proper safety precautions are to save from a current or a high voltage. It means the first our device will be grounded. Grounding is the main path to secure or a safe from a current or any accidental. So we have many topics about that type of the proper grounding about the devices of electrical, but we are discussing the best practice in the power substation grounding. We are discussing about that, and please subscribe my channel. Still not subscribed yet. We are discussing the grounding grids. The substation grounding system is an essential part of every electric system. The proper grounding of a substation is essential and very important for the following two reasons. First, it provides the main dispatching electric current into the earth without exceeding the operating limits of equipment. And the second, it provides a safe environment to protect the personnel in the vicinity of a grounding facility from a danger of an electric shock under a fault condition. Means first we have that the grounding is the main thing which will be trip or protect the device from damages, and second one is the safe environment to protect the personnel into the vicinity of a grounding facility from a danger of electric shock under a fault condition. If any person or any engineer or any worker which is working on a device, if any shock current or if a line is not insulated properly, then this current will be vicinate or an accident or cause the electric shock on your body. So so he is providing a electric shock under a fault condition. In a fault condition, when that engineer or a worker is operating their device, the ground system include the all interconnected ground facilities in a substation areas, include the grounding grid, overhead grounding wires, neutral conductor, underground cables, foundation in the deep well, etc. In our system, we have all these devices are an electrical things which is grounded. Substation area means in the area where is there, and overhead ground wires and our poles and other things are grounded, and also neutral conductor is also grounded at transformer or any underground cables are also grounded through their operating switch. Foundation where any switch or any electrical device are hold or mounted. Deep wells, also a deep sides are also grounded. The ground grid consists of a horizontal interconnected barrier conductor mates in the ground rods. The design of a ground grids to control the voltage level to the safe value should consider the total grounding system to provide the safe system at any economically cost. The grounding is also secure the economical cost or any damage which will be occur on the ground, and ground will be controlled their device from damages. The following information is mainly concerned within the personal safety. The information regards to the grounding system, resistance, ground current, and a ground potential rise can also be used to determine if the operating limit of equipment will be exceed. Means if amperes will be increased, then it will be will their safety will be operate through a grounding concerns. Safe grounding requires to interconnect of a two grounding system. Here we are discussing about the two main types of a grounding. The internal grounding of a switch or a substation consists of a grounding system buried at a some depth below the earth's surface. Internal grounding are also a type of grounding, and the second one is type the accidental grounding, temporary, the establishing by a person exposed to the potential gradient in the vicinity of a grounding facility. Means a major accident will be caused if the grounding will not in a substation. Temporary current is goes in that and it will be grounded, and the current will be run toward the grounded, not from that body of a operating worker or an engineer. It is often assumed that any grounding object can be safely touched. Means before you operate anything, you will be required to operate or touch them and check their grounding properly. Although substation's grounding resistance is not in itself a guarantee of a safety, it is a no simple relation between the resistance and the grounding system as a whole and the maximum shock current to which a person might be exposed. Means a grounding level for a substation is required properly. If a grounding is above to the ohms, 1 ohm means its grounding is not properly. Below the 1 ohm, the grounding is properly. Check their resistance. A substation within a relativity of a low grounding resistance might be a dangerous, while another substation within a high grounding resistance might be a safe or could be made a safe by carefully design. At that point will be explained that a substation within a relativity of a low grounding means low grounding resistance means it does be a high resistance means just like a 3.5 ohms or a resistance of that grounding. If a substation is designed on a below 1 ohm resistance, it will be carefully and safe for operation or any operating properly, that it will be working properly. There are many parameters that have effect on the voltage in around the substation areas. Since the voltage is a site dependent, it is impossible to design a one grounding system that will be acceptable for a location. Means there are many parameters are installed in the substation. Need you three or four grounding rods on near to the substation to complete their grounding properly. It 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 the acceptable for all locations. The grid current fall duration, soil respectively, surface material, and the size shape of the grid all have a substantial effect on the voltage in and around the substation areas. When the grid are a high current respectively and the resistance is depend upon there. If a ground level is depend upon uh, 10 feet or a 30 feet hole and then will be dug the rod there. You need to be a more than means we have to needed a 1 ohm resistance for that purpose. If a geometry location is a grounded electrode, a local soil character, and the other factor contributed to an exclusive and potential gradient at the Earth's surface, the grounding system may be inducted from a safety accept and the depth capacity to carry the fault current in a magnitude and the duration is permanent by a protective relay. During the typical ground fault condition, unless a proper precautions are taken to design the maximum potential gradient along the Earth's surface, may be of a sufficient magnitude to enter our personal area. Personal area. The personal area does to be a proper grounding is required for a substation. Average and last our message. Everything is depend upon the company and their ISO. Also, these things are discussed in the ISO that the proper grounding or a proper grounding is also safe for us and also safety for a device that is operating on a high voltage or in a low voltage. The main purpose of that video is more our hazardous voltage may develop between the grounded structure or equipment frames and nearby earth. Means earth is the main thing which is required for a hazardous voltage or a hazards voltage which will be effect on our structure, infrastructure or any our electrical devices or person that working on that device. Thanks for watching my video. Please keep subscribe me. Thank you. Allah Hafiz.